third type of method in order to solve quadratics is using the quadratic formula. Just like completing the square, or when I talked about your standard form when you're graphing, it's best if you have it in the form of ax squared plus bx plus c, and that equals 0 in order to find our roots or our solutions. With that, the quadratic formula and its base, the quadratic formula uses the a, b, and c from our quadratic equation in standard form. So in order to find our roots, it's going to be x equals negative b plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. Okay, so it is a big formula, and I do expect you to know this. But again, you're just using the coefficients in front of that x squared and that x. For example, if I were to have x squared minus 10x equals 24. So right now, currently, this does not equal 0. So I need to make it so it does equal 0. So I'm going to subtract that 24 from both sides. I now have x squared minus 10x minus 24 equals 0. So now that I'm in proper standard form, I can use my quadratic formula in order to determine my roots or my solutions. So my a value equals 1, my b value equals negative 10, and my c value equals negative 24. Notice the signs in front of it carry over with the b and the c. So because it was a minus 10, it's going to be a negative 10 for our b value. So now all we need to do is plug this right into our quadratic formula. So you have x equals negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times negative 24 divided by 2 times 1. Now, I do not do all of this at once. I break down the determinant, this discriminant, and that's underneath the square root. So I've got x equals 10 plus or minus the square root of 100 plus 96 divided by 2. Which gives me x equals 10 plus or minus the square root of 196 divided by 2. Sometimes your square root will not actually come out to an integer, and we'll talk about simplifying integers simplifying square roots and how you can rearrange those. But this one does come out to an integer. So we got 10 plus or minus 14 divided by 2. So I break this down into 10 plus 14 divided by 2 and 10 minus 14 divided by 2. When I do this, I get 24 divided by 2 gives me 12 as one of my answers. And then I have negative 4 divided by 2, which gives me negative 2. And if you wanted to double check, you could take that 12 and that negative 2 and plug it back into your original. So right here, you could plug it back into your original and see if that is in fact true. So to give you an example of when this might not actually work, or I shouldn't say work, but not simplify. Let's say that I have x squared minus 3x minus 2 equals 0. My a value is 1, b value is -3, and my c value is -2. So I've got x equals -3 plus or minus the square root of -3 squared minus 4 times 1 times -2 divided by 2 times 1. So this gives me x equals 3 plus or minus, we've got 9 plus 8 gives me 17 divided by 2. So in this case, the square root of 17 doesn't simplify, so you can leave your answer in this form because it does not simplify. Now, remember, at this point, you cannot have a negative number underneath your square root. So if you were to happen to get, say, a -10 underneath your square root, this would give you no solution or no real answers. We will talk later on about complex numbers and imaginary numbers in order to make this work. But at this point, you are not going to have to worry about that. Again, the quadratic formula is used in order to find your roots, and there is a program on your calculator, on the my graphing calculators, I should say, that'll help you find your solutions, and we'll talk about that when we're in class.